All right, kids, I know you're getting tired. Let's do another example. Let's calculate f prime of 1. Well, let's stop with 1. Let's make it 2 this time, just for fun. F prime of 2 for a new function. How about f of x equals x cubed? Or let's make it more interesting, x cubed plus 1. I don't know. I'm making things up as I go. Okay? So they want to calculate f. Now, algebraically, this is really, really easy. You know what this means, don't you? This means the slope of the tangent when x equals 2, which means that it's going to be the limit as delta x approaches 0 of f of 2 plus delta x minus f of 2 over top of delta x. Now let me stop here. Now, if I was doing this question myself, I wouldn't stop here. I would keep going and I would finish the question. But I want to explain what's happening here. So there's a difference between me teaching and how you would do it. You would not stop and do a diagram. You'd keep going and finish this, okay? But here's the diagram. This is f of x equals x3 plus 1. And you're coming out to 2, and you're going up to 9. Because 2 going in here is 2 cubed is 8 plus 1 is 9. So what you're doing is we're going to add a delta x, a little bit over a new point. So we got 2 points. We got this point P, and we got this point Q, right? And this point Q is designated by 2 plus delta x. Do you see what's happening here? So this is my first point, my second point up here. This is f of 2 plus delta x. And this one is f of 2, which, as we know, is 9. So this is y2 minus y1. That's what this is. Okay? And we're allowing this delta x to approach 0. So in other words, this q value is getting closer and closer and closer to the p value until we're getting the slope of the tangent. Close enough. That's what's happening. Okay? So, and again, if I was doing this question, I wouldn't have stopped and done that. But this is what's going on in my head. If I was doing the question, I would have just kept going here. The limit as delta x approaches 0. Now, what is the function? It's 2 plus delta x cubed plus 1. Subtract 2 cubed plus 1, which you'll remember is 9. So I could have just put in 9 there if I wanted to, over top of delta x. So now this is going to be the limit as delta x approaches 0. Now this is cubed. Oh, I shouldn't have picked cubed. That's going to be so hard. So it's going to be 2 plus delta x squared times 2 plus delta x plus 1. Subtract 9. I'm not going to fool around. I'm just going to make that 9 over delta x. This is going to be the limit as delta x approaches 0. This is 4 plus 4 delta x plus delta x squared. 2 plus delta x minus 9. I suppose I can do the minus 9 and just get negative 8. Can I? Yeah, I think so. There's no reason why I can't. Okay. And now I need to multiply these two guys together. So limit as delta x approaches 0. So 2 times 4 is 8 plus 8 delta x plus 2 delta x squared plus 4 delta x plus 4 delta x squared plus delta x cubed minus 8 over top of delta x. Oh, you can't see what I was doing. I'm sorry. And nobody screamed at me. Oh, well. So now this goes away. And let's collect like terms. I got 8 delta x's plus 4 delta x's is 12 delta x's. I've got 2 delta x squared plus 4 delta x squared, that's 6 delta x squareds, and plus 1 delta x cubed. You do realize that if I take the limit at this point, I get 0 over 0, which means I still got some work to do. So this is going to be the limit as delta x approaches 0 of delta x, 12, plus 6 delta x, plus delta x squared, over top of delta x. The delta x will reduce. We're going to turn the limit on. Ring ding ding ring ding ding. This goes to 0. This goes to 0. It leaves me with slope of the tangent equals 12. So I gave you a question that has some good algebra to it. I'm going to expect you to be able to do that. That's not hard. That I totally expect you to be able to do. Keep it straight. Go through it. So we found the slope of the tangent right at this point. Oh, you can't see. Let me zoom out. The slope of the tangent right at this point, right at P, is going to be the slope of that tangent at x equals, what did I say, 2? Is equal to 12. So what I want to do next is I want to calculate the equation of that line. Okay, we're going to do it just the same way as we did the other one. The difference, do you want me to try to, no, I should flip it over. So we want the equation of the tangent line to f of x equals x cubed plus 1 at x equals 2. So we're going to make use of y minus y1 equals m x minus x1. So you need a point. You need a point on the tangent line. That point on the tangent line is going to be x comma f of x. So it's going to be 2 comma, put in 2 here, so at 2 cubed is 8, plus 1 is 9. So that's my point. I need a slope. We calculated the slope. The slope of the tangent line at x equals 2 was 12, was it not? Am I right? Okay, so we're going to get y minus 9 equals 12, x minus 2. So now y minus 9 equals 12x minus 24. 12x minus y, 15, equals 0. And again, you don't have to do this, but I am trying to explain what's going on. You have just determined the equation of this line. This line is 12x minus y minus 15 equals 0. Notice the point that's shared is 2 comma 9. I call that the point of tangency. And the slope of this puppy is 12. I think you're finally starting to see what's going on. So I'm going to pause there.